right, so in the same way that stars come in clusters, galaxies can come in clusters. And so this is our local group of galaxies. And our galaxy is the second largest galaxy in our galaxy cluster. So actually the largest galaxy in our group is going to be the Andromeda galaxy. Our galaxy is in the process of colliding with one of those dwarf galaxies, and we are absorbing it. But given enough time, all of these galaxies in our local group are going to be colliding with each other and absorbing each other until finally there's just going to be one gigantic galaxy. Now that might be hundreds of billions of years into the future when that's going to happen. But eventually galaxies, they do collide with each other and they are absorbed. So in approximately 4 billion years, the Andromeda galaxy is going to collide with our galaxy, and we are going to be absorbed into the Andromeda galaxy. Now, do we have to worry about our sun colliding with another star during this collision? Well, first of all, no, okay, because we said that the chances of stars colliding with each other are very, very slim. Okay, but what is going to happen, so as our two galaxies do collide with each other, dust and gases are going to be compressed, and it is going to trigger a flurry of new star formation in our galaxies when that happens. So notice the size. So we went from the size of an individual galaxy as being 100,000 light years across, and now we're talking about the size of a cluster of galaxies as being 10 million light years across. All right, now in the same way that galaxies can be grouped into clusters of galaxies can be combined into superclusters of galaxies. Now in this picture right here, the dots in that picture are not stars. Actually, they're not even galaxies. So the individual dots in that picture represent clusters of galaxies, and then those individual dots are coming together into larger structures, which we call superclusters of galaxies. And then our local supercluster of galaxies is called the Laniakea supercluster, and also contains the Virgo, Hydra, Centaurus, Peo, Indus, and Southern Galaxy clusters. Okay, superclusters form in the cracks of where bubbles come together. So imagine that you're taking a bath, a bubble bath, okay, so that when you agitate the water, you got all of these bubbles. Okay, where the bubbles come together in the cracks is where the soap is concentrated. So similarly, the universe on the very, very largest scale consists of bubbles. And then where these bubbles are coming together is, that's where you're going to have these superclusters of galaxies are going to be concentrated. And the bubbles themselves are called cosmic voids, and they are up to 100 million light years across. So again, look at the scale. So this scale here is 2 billion light years across, as opposed to the scale for the cluster of galaxies, which is 10 million light years across. Now, this is not even as large as we can make it. So with modern telescopes, we can see basically back to within 100,000 years of the formation of the universe. So we think that the universe is about 12 to 14 billion years old. So that would mean that the universe that we can see, the observable universe, is going to have a radius of between 12 and 14 billion light years. And now this picture here has a radius of only 1 billion light years. So that as our telescopes keep getting bigger and better, we're starting to observe more and more structure in our universe. Now the universe is actually even bigger than 12 to 14 billion light years in radius, because we can only see that part of the universe that light has had a chance to travel. So the actual size of our universe could be up to 150 billion light years in diameter. All right, so this is just to kind of wow you here, so that the distance from the sun to the earth is 1 astronomical unit, or 8 light minutes. The distance out to the edge of our solar system, or the edge out to where Pluto is at, is 40 astronomical units, or 5 light hours. If you want to get to Alpha Centauri, then that's going to take you 4 years to get out there. So it's 4.22 light years. If you want to go to the center of our galaxy is 100,000 light years across, but we're closer to the galactic bulge. So if we wanted to go to the galactic bulge, that's 28,000 light years. And then if we wanted to go to the Andromeda galaxy, which is in our cluster of galaxies, that's 2.5 million light years. If we want to go to the next cluster of galaxies, that's 11 million light years away. If we want to go to the next supercluster of galaxies, that's like 107 million light years. And then we mentioned that the edge of the universe, so again, let's put the Earth in the center of the universe, which it's not, but the radius of the known universe is something like 75 billion light years. All right, what do I want you to know for the exam? I would like for you to know the thing about the distance from Earth to the Sun, the distance from Pluto to the Sun, and the distance from the Sun to Alpha Centauri. So that would be what you should know. All right, let's take a break. And when we come back, we're going to try to figure out why does the universe have this bubbly shape.